The 2AIS, Why Conflating Predictive and Generative Systems Undermines Strategy. Policy and Practice Abstract. Organizations, policymakers, and practitioners routinely discuss AI as a monolithic technology, collapsing fundamentally distinct paradigms, predictive AI and generative AI, into a single category. This conflation obscures critical differences in how these systems operate, the risks they pose, the governance they require, and the capabilities they demand. Predictive models excel at pattern recognition within structured domains, while generative systems produce novel content across modalities. Even seemingly shared concerns, such as bias, manifest differently. Predictive bias typically reflects historical data inequities affecting consequential decisions, whereas generative bias involves problematic content creation and epistemic harms. This article clarifies the technical, organizational, and policy distinctions between these paradigms, examines the consequences of their conflation, and offers evidence-based frameworks for differentiated governance, talent strategy, and risk management. Effective AI strategy requires treating these technologies as distinct operational and ethical challenges. When an executive announces an AI initiative, a regulator proposes AI oversight, or a job posting seeks an AI specialist, a fundamental ambiguity often goes unnoticed. Which AI? The term encompasses at least two radically different technological paradigms. Predictive AI, including classical machine learning and supervised learning systems, identifies patterns in historical data to forecast outcomes or classify inputs. Generative AI, exemplified by large language models and diffusion-based image generators, creates novel content by learning distributions and sampling from them. Bomasani et al. 2021. These are not variations on a theme. They differ in architecture, training methodology, output characteristics, failure modes, regulatory implications, and organizational integration requirements. Yet policy landscapes, organizational charts, hiring practices, and public discourse routinely treat them interchangeably. This conflation shapes billion-dollar investment decisions, influences congressional testimony, determines which expertise organizations prioritize, and obscures genuine risks while magnifying phantom ones. The dual AI landscape defining predictive and generative paradigms. Predictive AI encompasses statistical and machine learning systems that map inputs to predefined outputs based on historical patterns. A credit risk model outputs default probabilities. A medical diagnostic tool flags likely pathologies. A recommendation engine ranks content. These systems optimize for accuracy against ground truth and are evaluated on metrics like precision. Recall, An Area Under the Curve, Molnar, 2022. Their value proposition is better than human consistency at scale in repetitive judgment tasks. Generative AI produces novel artifacts, text, images, audio, code, by learning probabilistic distributions over training data. GPT-4 generates essays. DALL-E synthesizes images from descriptions. AlphaFold predicts protein structures. These systems optimize not for single correct answers but for plausibility, coherence, and alignment with prompts. Their value lies in augmenting human creativity and productivity across open-ended tasks. The architectural divide runs deeper. Predictive models typically use supervised learning with labeled examples and task-specific architectures. Generative models increasingly rely on self-supervised learning at massive scale. Transformer architectures enabling in-context learning, and emergent capabilities not explicitly programmed. Wei et al. 2022. Where predictive systems are narrow and brittle, foundation models exhibit surprising generality. State of practice and critical distinctions. Predictive AI has achieved near ubiquity in high-stakes domains, credit scoring, hiring filters, recidivism prediction, insurance underwriting, and targeted advertising, Barocas and Selbst, 2016. These deployments are often invisible, embedded in back-end workflows. Regulatory attention has concentrated here. The EU AI Act's high-risk category largely captures predictive applications affecting fundamental rights. European Commission. 2021. Generative AI adoption accelerated dramatically following ChatGPT's November 2022 release. Spanning customer support, content marketing, code assistance, and document summarization, McKinsey & Company, 2023. However, deployment remains concentrated in lower-stakes augmentation rather than autonomous decision-making. Critically, the practitioner communities barely overlap. Data scientists building fraud models typically have backgrounds in statistics or econometrics. Those fine-tuning large language models often come from natural language processing or deep learning research. Job postings conflating these roles reveal organizational confusion. Requiring 5+ years of AI experience is meaningless when generative breakthroughs are less than 5 years old. Organizational and individual consequences of AI conflation. Organizational performance impacts misallocated resources and strategic confusion. A 2023 survey of Fortune 500 chief data officers found that 62% reported tension between predictive analytics teams and generative AI initiatives. With unclear reporting lines and duplicated infrastructure. Gartner. 2023. Companies create centers of AI excellence, attempting to govern both paradigms under unified policies, applying model explainability requirements designed for credit decisions to creative text generation, where explanations are often nonsensical. Governance frameworks that fit neither. Unified AI ethics boards face irreconcilable mandates. Algorithmic fairness metrics, demographic parity, equalized odds, make sense for hiring filters but have unclear application to an image generator's stylistic tendencies. Conversely, content moderation policies appropriate for generative outputs are irrelevant to churn prediction models. The result is often lowest common denominator oversight that underregulates genuine risks in both domains. Individual and societal impacts. Policy incoherence and regulatory gaps. The EU AI Act struggles with this conflation. Its risk-based approach categorizes systems by application domain, but technical paradigm influences risk profiles independently. Ville and Borgelius. 2021. A generative system producing persuasive disinformation might evade high-risk classification, while a low-stakes predictive model in a designated domain faces stringent requirements. The bias example. Two entirely different problems. Nowhere is conflation more damaging than discussions of bias. In predictive contexts, bias typically means disparate impact. A model trained on historical lending data perpetuates discrimination because past human decisions were biased. Barocas and Selbst. 2016. Mitigation involves fairness-aware algorithms, reweighting training data, or abandoning problematic proxies. Generative bias manifests as representational harms and epistemic distortions. An image generator might depict doctors overwhelmingly as white males or produce stereotyped depictions. Bianchi et al. 2023. This reflects training data composition, but there's no decision about a specific individual. Mitigation strategies, prompt filtering, reinforcement learning from human feedback, share almost nothing with predictive fairness techniques. Conflating these undermines both. Fairness audits effective for loan models are inapplicable to content generators, while focusing on generative representation might neglect consequential harms of biased predictive systems already deployed at scale. Evidence-based organizational responses establish paradigm-specific governance structures. Organizations achieving AI maturity recognize that unified oversight is a category error. Capital One maintains a model risk management function focused on statistical validation for credit decisioning, expertise honed over decades. When exploring generative AI for customer service, it created a parallel generative AI safety board with distinct competencies: content moderation specialists, red teaming experts, and intellectual property counsel rather than fair lending lawyers, Office of the Controller of the Currency. 2011. The two bodies coordinate on data governance but operate independently. Salesforce restructured its AI organization in 2023, creating separate product lines for Einstein, Predictive Analytics, and Einstein GPT, Generative, each reporting to different executives, Einstein to the Chief Data Officer, Einstein GPT to the Chief Product Officer, Salesforce. 2023. This structural separation clarifies accountability and prevents everything is AI dilution. Effective approaches include separate oversight committees with paradigm-appropriate expertise, distinct documentation standards, model cards for predictive systems, content policy specifications for generative differentiated approval workflows, statistical validation for predictive models, red teaming for generative technology-specific training for governance boards, develop paradigm-aware talent strategies. Microsoft's AI organization publishes distinct career ladders for machine learning engineers, supervised learning, feature engineering, and AI researchers, foundation models. Alignment. Job descriptions specify paradigm explicitly, attracting appropriate candidates. LinkedIn, 2024. JP Morgan Chase developed separate internal training curricula after early AI for Everyone programs satisfied neither audience. Applied machine learning for risk and finance teaches predictive techniques. Generative AI product development targets software engineers building customer-facing tools. JP Morgan Chase. 2023. Actionable approaches, competency matrices distinguishing predictive skills, statistical inference. A/B testing, from generative skills, prompt engineering. Alignment, hiring panels with paradigm-specific expertise, dual career tracks allowing deep specialization, translation roles. AI product managers who understand both paradigms implement technology-appropriate risk management. Anthem. A major health insurer deploys predictive models for utilization management with frameworks emphasizing pre-deployment validation, holdout testing, fairness audits, and ongoing monitoring for performance drift. Anthem Inc. 2022. Errors are typically detectable, incorrect denials trigger complaints and clinical review. The company invested in explainability tools supporting appeals processes. Spotify faced different challenges deploying generative AI for podcast transcription. Validation against ground truth is impossible, and risks include copyright infringement and hallucinated metadata. Spotify. 2023. Mitigation emphasizes content filtering pre- and post-generation. Human-in-the-loop review for high-visibility outputs. User feedback loops and explicit disclaimers about AI-generated content. For predictive systems, rigorous holdout validation and demographic fairness audits, real-time monitoring for distribution shift, explainability tooling supporting accountability, clear escalation paths for consequential adverse actions. For generative systems, red teaming and adversarial testing, content safety filters with human review for edge cases, user feedback mechanisms to surface subtle failures, transparency about AI authorship and limitations, differentiate regulatory compliance and communication. When Humana deployed predictive models for care management, it engaged regulators with detailed validation documentation, standard practice for predictive health AI. Humana Inc. 2021. When piloting generative summarization for clinical notes, it recognized existing frameworks didn't apply and proactively shared content safety protocols with regulators, avoiding inappropriate compliance boxes. Organizations should maintain separate disclosures for predictive and generative deployments. Use paradigm-specific language in public communications, and engage regulators proactively when deploying novel technologies. Building long-term organizational AI capability, cultivate paradigm-specific centers of excellence. Google's historical separation of brain, deep mind teams, generative and foundational research, From applied machine learning teams in products, search ranking. Ads optimization exemplifies this model, Dean, 2021. Each center develops paradigm-appropriate standards and tooling. Coordination happens through architecture review boards and shared infrastructure. But governance remains separate. Smaller organizations can achieve similar benefits through virtual centers of excellence. External partnerships with universities or guild models where specialists share knowledge. Develop adaptive governance frameworks. NVIDIA publishes annual reviews of its AI governance framework. Explicitly tracking paradigm-specific policy evolution, NVIDIA. 2023. Recent updates included new guidelines for synthetic data from diffusion models, generative specific, and enhanced monitoring for real-time inference, predictive specific. The company resists one-size-fits-all policies. Organizations can build adaptability through horizon scanning processes. Sunset clauses requiring periodic policy review, pilot programs testing governance approaches, and external benchmarking against peers. Foster cross-paradigm strategic thinking while governance should differentiate. Strategy must consider interactions. Amazon's recommendation ecosystem illustrates productive integration. Predictive models forecast purchase propensity. Generative models create personalized product descriptions, Amazon, 2022. Systems operate under different governance, but product managers coordinate their interaction. Strategic considerations for hybrid systems include error propagation, responsibility gaps when failures occur, capability planning, and whether combined systems create novel risks absent in either alone. Conclusion: the conflation of predictive and generative AI is not semantic quibbling but a strategic and ethical failure with measurable consequences. Organizations can no longer afford generic AI strategies. Effective approaches require paradigm-specific governance structures, differentiated talent pipelines, technology-appropriate risk frameworks, and clear communication distinguishing which AI is deployed. For policymakers, the imperative is equally clear: regulations must account for paradigm distinctions or risk irrelevance. Fairness audits designed for credit models don't translate to content generators. Content moderation frameworks don't map onto predictive health tools. Organizations that develop paradigm literacy now, building distinct capabilities, governance, and strategies, will navigate the next decade of AI evolution with greater clarity and responsibility than those clinging to the fiction of monolithic AI.